speed and in one direction without any change in any factor. No change in direction, no change in speed. So a guy falling down reaches a terminal velocity due to the wind pressure acting up on him. So the gravity is pulling him down. The wind pressure is pushing him up. At some point, it balances it out. Okay, it's equal. The amount of pressure that is pulling is equal to the amount of pressure that's acting up on him through the wind. And that is the point where we call that guy reached terminal velocity. Okay, so that from that moment on is going to be constant speed. And normally speaking, you can go research, but it is when a guy or some body falls, it is 140 miles per hour. Okay, something around that. And do not move things, so you are going to like tip it up. Okay, all right, now we are going to see that terminal velocity in action. We are going to do an experiment. Okay, we are going to do a simulation. We cannot like jump from the plane, unfortunately, and observe that. Instead, this is close to that. So now we fill this with a constant, which is clear. That's the whole point. And it is viscous. It is not like water. Water is less viscous. That is, it flows freely. It has a little bit dense. Okay, it's a little bit dense. So you put something, it's going to go slower. Okay. So now the terminal velocity is going to be affected by a lot of things. Okay, one is the surface area. So the guy, like if he spreads out while falling down, he's going to go a little bit slower because like a lot more pressure is acting up on him, and that's exactly why the parachute is like acting to slow him down because it is a lot more surface area, right?
So
Hold on. No. Let's not talk about this. Focus on what I'm saying. Surface area that affects the terminal velocity. Got it? Because a lot more pressure is acting up on him. Do you understand? Guys, follow it. Good. So now, at some point, he's keep on acceleration. The moment he jumps, he accelerates. That means you can observe that he is going faster and faster. And at some point, he is going to slow down. Let's not worry about the moment he opens the parachute. That's called deceleration. The speed is going to decrease. Okay? That means the wind pressure is much more than the gravity. So something is pushing up against him, a lot more than the gravity. That's the reason why the speed falls. But let's not go over there. We're talking about terminal velocity now. Okay. So I got some collections here, right? So a couple of marbles. No, don't touch anything. I'm going to do the entire thing.
a spoon.
You will get everything back, okay? It's all Vishnu's, but you will get everything back, don't worry. Alright, so I got some collections, couple of marbles, which are spheres, which is round and smooth. Let's see how that affects the terminal velocity. Okay? Some rock, which has like a weird shape, but it has a lot more surface area, but it is heavy, right? And then some coins, like this is flat. Let's see how that goes. And these are some pebbles, which are like a little bit smaller, right? And this has this smooth, but it is not like marble. It's kind of a marble, but it's like a bit flatter. So now, before we do this experiment, let's do one thing. I'm going to draw this object. What do you expect to observe? Let's go from here.
It's gonna be going down because it's heavy.
Yeah, that is one thing. You?
I feel like it's gonna be like the thing we saw on the video where like there's low pressure,
Can you move over?
like there's low pressure, like there was a vacuum and then like the vacuum. I think we're gonna see where like the bowling balls are just, like at the same speed as the.
No, that is vacuum. Okay, there's nothing to block or like have some pressure on that. So the feather and the bowling ball is going to fall exactly at the same time,
Or I
irrespective of the
think
weight.
it's gonna like push itself through like that thing and then like do it.
Okay.
Or it's just gonna stay on the top.
Okay, let's talk about that. Do you have any thoughts?
It might go faster than the flat edge rock because
Let's talk about only this. Let's not compare. Only this. If I drop, what happens?
It'll go faster than that.
No, I'm not comparing.
There's no comparison here. We are
at this
just
moment.
this is the first action, right?
Put your thing.
From the guys, draw a parallel, okay, from the guy jumping. So just imagine this is the guy and this is the airplane door. The moment he jumps, it is going to accelerate because of the gravity. You see, like this is on dropping, so it is going down, right? And it is going at a speed, 10 meters per second, acceleration. Okay,
Okay,
so
let's
just
stop
keep
and
on
see.
accelerating. But at some point, it is going to, from here on, this is the edge, okay, this is the edge of the liquid, right? So it is going to go maybe until this point, it is going to accelerate. That means it is going to go a bit faster. After some time, it is going to maintain constant speed. Everything has, this has upward pressure, right? This is a liquid, just like wind or air. So this has resistance. So it is going to have this, it is going to reach terminal velocity at some point, maybe here, maybe somewhere, okay? So any of you have like a marker, like a Sharpie or something? Yeah, check.
I have-
We can even mark it up where exactly it is.
I can give you like a.
I don't want like too much wasted time here. If you don't have it, that's fine.
Pencil, chalk will work actually.
Yeah, chalk might work too. No, that's fine.
That's a pen.
It's not a pen. Okay. Something like this.
All right.
That will work.
Yep. All right. So let's see. Okay. Let's see like what happens.
Wait, let me come here then.
Okay.
stop blocking
not
the view.
block.
Don't block the view.
You don't need to go. Everybody can see. It's like exactly the same view from all angles. Got it? Let's drop. Let's see.
Oh,
Oh my god, look at that.
So it is going down. It is going at a constant speed. Now it's slowed a bit. Like it was a bit faster in here, but I see it is a bit slow in here.
It looks like a dolphin.
And then it stops there.
I-
Let's do one more. Okay?
Let's take it out.
Okay,
Yeah,
watch
take it off.
carefully what is happening there,
Okay.
right?
Mine, remember, it's mine.
Hey. Yeah, you can watch. Watch the speed. That is the important thing. That's what you are looking for. Do you understand? The speed. How it changes, the acceleration. How fast it goes, how slow it goes. It goes a bit faster. I would say here.
yeah, it slows down.
It slows down like noticeably right there. It happened with the other marble also.
Wait,
Okay?
Right there.
We'll
Somewhere
just mark
around
it
here.
Yeah, we marked it.
Okay? Stop it. All right, now let's try something which is an odd shape, which is not a sphere, which is still smooth, and it is like about same weight.
Actually, I
Okay.
think it's gonna stop
Yeah.
full, and it's gonna.
You have to drop it from the same height. Every
Yeah,
time.
we'll drop on the same height.
It's going to stop moving
Good,
fast,
good observation.
slower because in less time because it has more surface area.
Good.
I
So
feel
this
like
one observation, we'll see what happens.
I feel like you should do one
Yeah, we
time
should
on
have a
like the
timer
side
to
and
time
then the other time like on the flat side.
Right. Okay. Okay. Let's see.
Flat side.
Yeah, I'm doing the flat side.
Yeah.
Wow.
Much slower right there. It's speeded up. It's still going about the same speed.
11.
And now it's slow.
It's slowed right here, I would say.
I want to see it again.
There's
On,
no-
but like on the like.
Okay,
the
this
round
is a
side.
similar marble. Okay, not exactly the same
But
size.
like pretty much the same.
Let's see what happens here. It stopped right there when I put it right. Now it is a little bit like faster.
Fast, fast.
Slow.
I think it's slowed a little bit
Like
here.
right there.
Slow.
Now it gets like
Right
very slow.
here.
It gets- Yeah, it's
I think it's slow right
little down. Yeah, around that.
Right. Okay. Let's do a coin. This is a heavy coin. Okay.
I feel like it's.
Vaishnav, do not touch anything. Stop saying that.
We are recording.
after.
You don't need to see. You can see that all later. Okay.
I feel like it's.
So
just
let me
gonna,
drop like this side.
It has
Oh, you know what? Let me drop it flatter side. This is a heavier coin. Okay, I'm going to drop flatter side. Let's see what
I
happens.
feel like it's gonna go like
It's an
fast, but then it's gonna get slower. Like
It's 5 rupees.
It always does that, but let's see what happens. Much faster than the other two.
But then it's.
It's slowed about here.
Can I see? Hey, can you?
Okay. Now I'm going to have another coin which is much lighter weight. Let's do the same way, flatter side.
It's 1 cent.
Once.
It literally stopped right there, and then it accelerated, right? It is going pretty much the constant speed. I think through maybe over here it stopped.
And up there.
Okay. Now I'm going to drop the coin like this, flatter
So now we
side.
are putting in a different direction now.
Vishnu. Okay. Right?
Same coin.
Much faster than the other coin. It is pretty much constant,
Right.
and then at that point it's
At
low
the very bottom, it slows down.
at the bottom over here. Okay? And if the tube had extended a lot more, right? Then it would have been like constant at that moment.
Then it will be.
Okay, let's try one more coin. It's again like it's speeding up a little bit right now, and then I think it is constant a little bit. And I think at this point it's slowing actually.
Yeah.
It's not even constant, it's a little bit slowing at this point.
When is the
Okay, so let's look closer. Okay, now our pebble. Okay,
Wow. It looks much bigger.
it is slow right from the top, much slower here.
Now. Oh.
It actually stopped right there.
It's slower right there.
Uh-huh. Okay, so now one of you guys count. Okay, let's count the seconds. Okay.
I want to count it.
1001, 1002 is the counting.
Okay.
What?
1,002, 1,003.
Okay, so you count. So this is how you're gonna count. Okay. So now the moment I drop, I will say start. Okay, and then let's do this. I want two counts actually.
I'll count the second. Like so.
Okay, let's do that.
1,002, 1,003.
Okay, good. So the first I will say, I will drop, you start the count. The moment I say stop, you stop, and you start immediately. I'm not going to say start. You start. The moment he stops, you start immediately. Okay?
And then
Let's
we-
see. The next time.
Next time.
Okay? Ready?
Yeah.
Okay.
Start.
Say it loud.
1,005, 1,006, 1,007, 1,008, 1,009, 1,010, 1,011, 1,012, 1,000.
All right, that's fine. 12 seconds. Let's do a different thing in here.
It was 13.
So the thing is, the reason why I did not stop is I did not notice any change in speed.
Because
Okay.
it's constant. So
It was pretty much constant right from the top.
So write it. I'll write it.
So maybe like a bigger one.
Yeah, this I think pretty. I have a feeling it will work.
I
You
want
ready?
him to count.
So count louder, not with, for you. Count louder. The moment I say stop, you start, and count louder. Ready?
And then me.
Yeah, later. Okay. Good.
1,002, 1,003, 1,004.
Stop.
1,000.
1,005, 1,006, 1,007, 1,008, 1,009.
Stop. All right. So here you said 4,
Yeah.
right? At this point when I marked, it was 4 seconds, and then in what is that?
1,009.
Yeah, it is like 5 seconds, close to 5 seconds. So the observation is from the top right here until this point, okay, until this point,
Most of that
Which is
much.
it
more
is
than
4
half.
seconds,
which is more than half, right?
right?
Yeah.
Right? Until this point, it is 4 seconds. From this point until here, it is 5 seconds.
It
Okay?
doesn't make sense.
Okay, let's talk about that. So this is a much, much further distance.
Yeah.
Agreed?
Yeah.
It took only 4 seconds.
That doesn't make sense.
Let's talk about that. Hold on. I'm just like observing. You understand? But from here to here, it took about like another 4 seconds or 5 seconds, 4 to 5 seconds.
5.
So I think it got slower at the middle, and then so like by 1 second it got slower, and then it started going like at
Exactly.
the top, it was like, but when it reached the middle, it was like that.
Right.
So it's
So what happened is, so a couple of things happened. One is it was accelerating throughout this point, very little, okay, but it is accelerating. That's one reason why the speed is like like building up, right? So that is one reason why it traveled a lot further in 4 seconds. However, the fluid has a lot more weight at the bottom. Do you understand why is that?
Maybe because like the pressure, the gravity is pushing it.
No. It's
Or
the
like
pressure from the top. All these liquids from here to here, right? It is all pushing down on this area.
Like the thing it said in the video where like if you go like down in a swimming pool, you'll feel like a bunch of pressure.
Exactly. You cannot like
I
keep
feel-
going down
I feel
at
like
some
it's
point.
the same thing.
Yes. And there's another
The
reason.
pressure is coming from the water in the swimming pool, right? If you're on the
Yeah.
surface, there's
So,
no
like-
water above you.
If you go to like the ocean and then just jump off a boat with like scuba diving gear, like once you reach the bottom, there's gonna be a bunch of pressure on you.
Exactly.
Like-
Yeah.
So you actually need like a weight to make you sink. You need to carry some iron, whatever, weights.
Yeah.
But
Lot
then,
of-
And
like,
once
if you
you
want to
reach
come
down-
back up, you need to like take off the weight.
Exactly. So that acts like a parachute in a way. That
Yeah.
weight itself, right? That's the reason why it slowed down a bit. But more importantly, at one point, like maybe over here somewhere, right, it reached the constant velocity. It's not going to accelerate anymore. So until from here to here, it travels in exactly the same speed, and then it started slowing down. Exactly like what we saw from the guy jumping. He, like he accelerated from here to here, right? And then he reached some constant velocity. Since it's very little and it is actually like going a lot slower, we didn't observe it much. But he reached the constant terminal velocity at this point somewhere. At this point, he traveled a bit, and then it started slowing down a bit. Okay.
So it's basically like he's accelerating is when he never put the parachute, and then like at this distance, he like for example, wherever the coin was, it's like if for example if you put the coin over there, then it put its parachute over there.
Kind of. There's another reason. We put like two types of liquids. Both are corn syrup, but it's two different brands. So maybe one thing is a lot more like viscous. Another
And
one is
maybe,
like
like,
less.
Yeah,
one
the
of them
first
is,
one
like, at
was
the
more viscous.
Like one of them is like way at the bottom, and that's
Yeah.
more
It
dense.
is.
And this one is
Yeah, we
like,
didn't mix it up, so because of that, one liquid is here, another
See, if
liquid
you
is here.
observe, one is little more yellower and the other on the
Right.
top is like little white.
Right? So at this level, probably that is the reason. But
Yeah.
the principle is exactly the same, no matter what. Whether it is air, water, like corn syrup.
we can mix it up and see, put another pebble and see what difference does it make.
what about these?
But now we'll do the second part of it. We are trying to mix up
Can
the
we put
syrup.
the cap in
Guys,
there?
we're trying to mix
in
the
there.
syrup and see how does it make the difference. We're mixing it up now.
You're gonna put this.
And maybe if you have water, right? Maybe you can pour some water also to make
Take
it.
your water from there, like from the water fountain out there.
Or like, do you have a water bottle?
Yeah, your water bottle. Donate some water.
No.
Then it's gonna be spit, and his spit is gonna be in there.
You can put water on the top, right? The syrup will stay up. The water should float in the syrup, right?
You're not putting your spit in there.
Hey, do I have some water here?
I'm not donating it because
Oh, come on.
spit is gonna
Okay, I'll go get some water. Come back and sit.
Look, can I come with you?
Huh?